Let's begin. Today's November 21st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 7, 8, 19, 20, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at our last digit, the circle digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our 3-digit solution, and the Turing machine will let us know how many ones there are. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card D will take a look at our first 2 digits, triangle and square, add them together, and compare the sum to the number 6. So should the value of the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, it can let us know whether there are no repetitions, as in the example 125, or it can inform us that there is a double number, as in the example 112, or alternatively, it could be a triple number, a single digit repeated 3 times, as in the example 222. And finally, criteria card F, again, we'll take a look at our 3 digits from triangle to square and circle, but this time it'll let us know something about the order of the digits. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135, or could inform us that the code is in a descending order, or basically that they're decreasing, as in the example 421, or alternatively, the 3-digit code may have no order. Now let's take a look at the example of 231. Notice that when it goes from 2 to 3, it increases, and then from 3 to 1, it decreases. Of course, it could also appear as decreasing and then increasing, but nonetheless, it's that shift from one to the other that can define a 3-digit code as having no order. Now, we've seen other puzzles where if you have consecutive equal digits, that can also exhibit no order. So let's take a look at the example above of 112. So when it goes from 1 to 1, it neither increases nor decreases. That, again, is one way to define a 3-digit code as having no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing machine does not approve of my choice for circle. Notice that I did choose an even 4, but since the Turing machine does not agree with that, it's informing us that circle should actually be odd. So let's go ahead and type that up in our notes in section B. And we'll say that circle is an odd digit. And of course, since it is odd, let's go ahead and cross out the 2 evens. So crossing out 2 and 4. The next thing I think I'd like to test is criteria card E. Okay, so the Turing machine does approve of my choice of 314. Notice that 314, all the digits are distinct. There are no repetitions, and the Turing machine confirms that. So let's go ahead and type that up in our notes for section E. And we'll say that the solution has no repetitions. Okay, and again, because there are no repetitions, all the digits are distinct. I'm not sure if that helps us eliminate any possibilities, but let's see, what else can we test? Well, let's go ahead and test criteria card D. Okay, so the Turing Machine does not approve of my choice. Again, D is looking at the first two digits, 3 and 1. So when I add up 3 and 1, I get 4. 4 is less than 6. But since the Turing Machine does not approve that, it must be one of the other two possibilities. So either the sum of the first two equals 6 or should be greater than 6. So let's go ahead and type that up in our notes in D. And that is that triangle plus square is either equal to or greater than 6. And I don't think we can cross out anything because of the equal. You could have 1 and 5, and then everything in between potentially could be solutions to the sum of the first two being greater than 6. The only thing we can say is that we shouldn't consider two small choices for both triangle and square. So, for example, 1, 2, you shouldn't consider, or even 1, 4. But yeah, 1, 5 should be considered, and then 2, and then other large ones. So no too small. But that in itself does not allow us to cross out anything. And we have completed our 3 Turing tests for round 1. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, testing our triangle digit to the number 3. And we did not establish if there are any ones. Now remember that there are no repetitions. So if there is a 1, there's only going to be a single one or no one at all. And I guess we did not completely establish whether the sum should be 6 or greater. And then we also have criteria card F establishing what sort of ordering there might be. Okay. Well, let's see. Well, let's take a look at criteria card D and see, can we have a possibility of having a sum of 6? Well, we could have, let's see, a sum of 6 both with odds or evens. So if there is a 1, it could be that it's going to be 1, 5 or 5, 1 in some order. And I guess triangle would help us decide. Now, I don't think it could be equal to 3 because we are looking for distinct digits. So that might be helpful. So it could be something like 1, 5. Now the question of circle, well, circle is odd. And it could be, I guess it could be a 3 if all digits are to be distinct. Let's see. And would that help us out? Well, let's see. 1, 5, 3 or 5, 1, 3 are both no order. If there is no 1 and the sum is 6, well, then that would lead us to have 2, 4 in some order. But then how would you then choose circle? There is no 1, so it's going to be a 3 or a 5. So let's see, 2, 4, 3, 4, 2, 3. 2, 4, 5 would be increasing. 4, 2, 5 would have no order. I guess I am sort of leaning towards a sum of 6 with a 1, almost having an all odd solution. So let's go ahead, let's see. Yeah, and triangle would basically establish which of the 2 digits it might be. Well, let's consider though, what if circle is 1? If circle is 1, then it would force, I guess, the sum to use 4 and 2, since there's only a single 1 digit. How would that, the fact that it could be, well, or maybe there are no 1s. Two, 4. You know what? I'm still going to choose a sum of 6, but I'm going to use evens instead. And in fact, I think I'm going to choose 2, 4, 5. Perhaps the ordering is going to be increasing. Let's give that a try. 2, 4, 5. And so just to verify that last digit circle is odd, yes. We're testing that the sum might be 6 and there are no repetitions. Okay, so let's give that a try. Well, the whole point of it is that the sum is 6. So let's go ahead and test criteria card D again. Okay, yes, so the sum is 6. So let's cross this out. Okay, so the sum is 6. And as we stated before, there are no repetitions. So I feel pretty confident that triangle cannot be a 3, because that would force square to be 3. And similarly, square should also be crossed out for 3, because that again would force us to pick triangle 3. So yeah, so it's either going to be a 1, 5 or 2, 4. And let's go ahead and test criteria card C and discover if there is a 1 or not. Okay, so it does not approve of the absence of 1. Notice that, of course, my proposal does not have a 1 digit, and the Turing Machine does not approve of that. So again, because of no repetitions, if there's going to be there's either a 1 or not, it doesn't like the fact that I did not pick a 1. So I'm going to type it up as we're going to deduce that there should be a single 1 digit. So the solution has a single 1 digit. Okay. All right, so we do have a 1. The question is, where does it go? So let's see. So we've established that there should be a 1. Circle is odd. Let's see. Yeah, let's go ahead and test criteria card A. Okay, wow. So I did pick a 2 for triangle. 2 is less than 3, but the Turing Machine does not approve of that. So So it's not less than 3. We sort of already crossed out triangle to be equal to 3. So I'm going to type it up that we should deduce that that triangle should be greater than 3. So let's go ahead and type that up. And again, we're going to deduce that triangle should be greater than 3. And so that means that triangle cannot be a 1 or a 2. So I'm going to just adjust this and move it to the 1. And as we stated, it can't be 2. And of course, we had already crossed out the 3. And so what does that mean for square? Well, if triangle's to be 4 or 5, that means that square is either 1 or 2 because it has to add up to 6. So it can be 1 or 2, but square cannot be 4 or 5. So let's cross out 4 and 5. Okay, so let's see. Remember, we do need a 1 in our solution. So that's either square or triangle. So let's do this. I'm going to come up here and list out some potential solutions. So if triangle is 4, that forces square to be a 2, and we need that 1 digit. So it could be 421, and I believe that's the only possibility. If triangle is 5, that forces square to be the 1, and because of no repetitions, it would seem that the only possibility would be 3. So 513, yeah, because you can't choose 1 or 5 for circle. That forces it to be 3. So we do have a decreasing solution of 421 or a no order 513. Now, is there anything that would allow us to deduce the no order? I don't see anything, any kind of contradiction or any pairing of criteria cards that would allow us to deduce. Because just because you have a descending solution doesn't necessarily mean that circle would definitely be the smallest, but it wouldn't necessarily guarantee that it should be a 1, because it could be 432. Again, before even knowing that the sum is 6, there are lots of descending that don't have a 1 in circle. Well, okay. I believe, let me see. I kind of remember something maybe with criteria card E and F. So let's see. I think it went something like, if it's ascending or even descending, we would know that there should be no repetitions, because by definition, ascending and descending, you can never have equal digits. It's a guarantee that they should all be no repetition. So let me think about that. So if it's ascending, it would make criteria card E irrelevant, because ascending is no repetitions, and so is descending. So I think for that fact, I think we can deduce no order. Yeah, because if it's ascending and descending, it guarantees it to be no repetition, making this card irrelevant. So yeah, I think I'm going to say down here, we're going to deduce I'm experiencing a little bit of lag. And we'll say that the solution has no order. And again, the argument is that if it's ascending or descending, by definition, that means that there should be no repeating digits, making criteria card E irrelevant. Okay, so when you have no order, you could have repetitions. We just don't know. Okay, so for that fact then, if the solution is to have no order, I'm actually going to cross out 421. And again, it seems like we're still experiencing a little bit of a lag. Let me see, can I do this? No, it's not going to let me. Okay. Well, let's see, what's going to happen here? So 513 looks like the solution just to... Okay, what's going on? Can I do this? Okay, so a little bit of the notes were garbled. But again, let's see, can I... Yeah, I can cross out the 421, and I'm going to say that the solution should be 513. So let's cross out the 4. Let's cross out the 2. And of course, because of no duplication, can't have a 1 or a 5. So yeah, 513 looks to be the solution. All right, so is triangle greater than 3? It is. It's 5. That last digit is odd. It sure is. There is a 1 digit. The sum is equal to 6. Yes, no repetitions, and we deduce no order. Okay, well, let's go verify that 513 is our solution. 513. Fantastic. Well, how do we do versus our Turing machine? Well, this was a 6-card criteria card puzzle, and we did exactly 6 Turing tests, although we outright deduced F. We did do D twice. And so in the first round, we did B, D, E. And in the second round, we did the 2 remaining plus an additional test against D. So B, D, E in the first round. So B and D were incorrect. We did E, and that was correct. Second round, we did the 2 remaining AC, and they both were incorrect. But when we retested D, the sum of the first 2, it was 6, and we outright deduced F. So no need for that. Okay, so we beat the Turing machine by 1 question. Well, by far, recalling how criteria card E and F interacted, that, I believe, played a part in beating the Turing machine. Of course, we did have to test D twice, and we got the sum correctly at 6. That, I would say, was also helpful. But by far, just recalling this interaction definitely played a part in the win. Well, what about you? What sort of criteria cards did you pick? And did you notice anything interesting? Please add your thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.